Hi, so welcome once again to this lesson. We've done a lot of Numpy Array videos. We've done two of them so far, and we're still doing, right? So here, the first two that we did is what we call a one-dimensional Numpy array. The reason is that the dimension for that we only have one row, and that's what we had, right? So if you could remember, we converted this list, the weight and height list, into numpy arrays. You could do that by using the code below it, but today we're going to focus more on two-dimensional numpy array. Okay, so of course you have to first import your numpy as np. Then I've created a list weight. I've also created a list height. And suppose we want to create a two-dimensional numpy array with these two different lists. Of course, you can create this two-dimensional numpy array without creating the weight and height separately. And that will be the exercise for this video where you get to practice with what I'm talking about. Okay, you just have your list of lists and then you just create a numpy array using that list of lists. Okay, now I want to combine these two lists that I have into a two-dimensional numpy array, and I just run it, right? So let me rerun this place. I name it np underscore 2d, and then this is the code I use to write the normal np.array will give us a numpy array, right? But here the two-dimensional numpy array works in this case that the height is going to be one row and then the weight is going to be another row. So what we mean by two-dimensional numpy array is that we're going to have a row and column of whatever we have. Okay, so if I run this, it's saying this is an array, and if you look inside the array, we have this whole thing as one row and then the other side as another row. Okay, and then we have some columns. Now I'm saying that if I want to print this and look at how it looks like, I will just run this and see how this array look like. Okay, so this is how Python sees it: the whole of this row and then another row. So if you've taken matrices classes, you somehow you may refer to this as a matrix, or your knowledge that you use in matrices, you can apply the same things here. Okay, now I want to verify the dimension of this with a dot shape attribute, and what I'm going to do is that I'm going to print np underscore 2d dot shape. What this is going to do is that it's going to give us the number of rows and number of columns. So how many rows do I have? I have, so the first list in one box here, one square bracket here, is the first row. The other one is the second row. And how many columns? Just the vertical one. So these ones here, so 1.73 and 65.4 are in one column. So these two, sorry, I don't know how to select them, but I mean, I don't know if you see what I'm trying to say. The vertical ones are the columns. So 1.73 and 65.4 are in column 1. 1.68 and 59.2 are in column 2, like that, till you get to 1.79 and 68.7, which are in the last column. Okay, column 5. So we have 5 columns. Again, remember how you can index these. If I want to index for Python in terms of row, we have 2 rows, but then the first row has an index of 0, index 0 in Python. The second row has an index 1. Likewise, in the column, we have the first column to be 0 index and the last column to be index 4, having index 4. Okay, suppose we want the element in the first row and the third column of this numpy array. So we go to first row. Which one is the first row? This one. And then want the third column. So the third column, you have column 1, 2, 3. Remember, I'm just counting these. I'm not using numpy indexes. Okay, so I want to attempt this guy, 1.71. Okay, if I want to subset this, I'm going to use the same way we subset list np underscore 2d, but here what I'm going to do is I'm going to supply the 2d with the row number is row 1. Here the indexing is 0, and I want column 3. The column 3, the indexing is 0, column 1 and 2. So 0, 1, 2 for the indexing, right? So I have this. So if I print this guy, I should see 1.71, and that is true. So all that I'm trying to do here is go through the first row and look at column 3. This is 1.71. Take that element there. And let's select the height and weight of the second and third family members. Okay, so what we want to do is going to go through. Now if you realize how we created the two-dimensional numpy array, we have the height as one row and then the weight as another row, right? So we want to go through all these rows, select the height and weight of the the second and third family member. So the second and third family member, we can say this is the first family member, this is the second and third, right? So we want to select these guys, 1.768, 1.71, which will be the height, and their corresponding weight are 59.2 and then 63.6. Okay, so how do I subset that? I want to go through the whole rows, row 1 and row 2, right? So I can do this np underscore 2d, sorry, and then to select the whole row you use a colon, okay, comma, then in the I go to how I can subset 1.71 all the way to you want a second and third family, so we want 1.68, 1.71, and then 59.2 and then 63.6. So in columns, in terms of columns, the indexing for the first part column is 0, and then this one will be 1 and 2. So I'm going to start from 1, and then I want it to go all the way to 3. And the reason I did this is because we know from our previous lessons that Python would exclude 3. So it would start from column 1, subset everything, and then go to column 2, and that is it, right? We could actually go do 2.5 if you want, right? Just that you have to provide or supply it with something that is bigger than the last column you want it to subset. Okay, so if I print this guy, I should be able to see 1.68, 1.71, 1.71, 59.2, 63.6 as my subset that I want, my interest that I really want. Okay, so I have a little exercise here for you to go through, practice with a 2D numpy array. Create a baseball list of lists that contain the list. So I have this first list, second list, third list, and fourth list, right? Create a 2D numpy array from this baseball list and give it a name of your choice. So you can name it anyhow you want. Create a 2D numpy array for it. Print out a shape and comment in the comment section in this video the number of rows and columns you got. So here you're supposed to get 4 rows and 2 columns. Okay, I mean, I've given the answer, but you're supposed to get the same thing when you use the shape attribute that I use here. And also print a baseball numpy array you got. Okay, so I just want you to print it out. In our next lesson, we'll talk about how we can use some statistics or some statistical methods or tools and apply them on 2D numpy array. Okay, so see you in our next lesson.